Hello everyone, welcome to Casiano Easy Math. We have here a given square figure with lateral diagonals of length 5 units and another diagonal side length of 4 units. And if you notice, these sides are perpendicular to this line from this corner of the square. And in this video, we're going to solve for the area bounded by red ink over here on the upper part of the square. And before we start, I would like you to know that the figure is not 100% true to scale. Now we have to label this area, the region inside the square. So this is now region A, and this is now region B, and this is now region C. So in here, we're going to solve for the area of this region, region A. And to calculate the area of region A is we have to consider the whole square, subtracting area of region B and subtracting area of region C. We have here calculation of the area of region A, that is area of region A is equal to area of the square minus area of region B minus area of region C. And so now let's start with calculating the area of the square. So we're going to consider the sides of the square. So this is now indicated as x. And now to calculate the side of the square, the value of x, we are now considering region B and region C. And in this triangle right here, region B, if we call this angle over here as angle alpha, the other angle over here, we can name it angle beta. And these two angles right here are complementary. That means the sum of these angles is 90 degrees. And considering region C, if we have here angle alpha, since the corner of a square is 90 degrees, if this is alpha, then this angle right here must be angle beta. And if this is angle beta in region C, this angle then must be angle alpha. So considering these two regions over here, so these triangles actually are congruent triangles. So we can find the value of alpha, angle alpha, or angle beta. And once we found the value of the angle, we can find the side of the square. So considering region B or area B, so here considering area B, we have here sine of alpha is 5 divided by x. So this is now trigonometric function. Sine of alpha is equal to 5 divided by x. And considering area C, we can get the trigonometric function of cosine of alpha. So in here, we're taking cosine of alpha. So that is equal to 4 divided by x. So here now, cosine of angle alpha is equal to 4 divided by x. So from here, if you notice, we can take the sine of alpha over here and cosine of alpha. We're dividing it with cosine of alpha, that will be tangent of alpha. Since tangent of alpha here, tangent of alpha is the same way as sine of alpha divided by cosine of alpha. So from sine of alpha over here and cosine of alpha over here, we can solve for the value of angle alpha. So we have here now, sine of alpha is 5 divided by x divided by cosine of alpha, that is 4 divided by x. So simplify this equation. So this is now 5 divided by x times x divided by 4. So that is the value of tangent of alpha. And in here, if you notice, we can cancel the x. So we have here now tangent of alpha is equal to 5 over 4. And here calculating for the value of alpha, alpha is equal to arctangent of 5 divided by 4, or inverse tangent of 5 divided by 4. So in here, the value of angle alpha is now 51.34 degrees. Now that we have found the value of angle alpha, then we can get the value of this side of the square. So from here, considering the cosine of alpha is equals to 4 divided by x, since we have the value of angle alpha already, we can solve for the value of x. Here cosine of angle alpha is equal to 4 divided by x. We have here now cosine of angle alpha, that is 51.34 degrees, is equal to 4 divided by x. So x here now is equal to 4 divided by cosine of 51.34 degrees. Value of x over here now is equal to 6.40 units. Alright, so we have found the value of x. So now we can calculate the area of the square. So area of the square is equal to x squared. So area S, area of the square, is equal to 6.4 squared. So area of the square is equal to 40.96 square units. Now that we have found the area of the square, next thing to do is we need to find the area of region B. Considering region B over here, we have the opposite side, that's 5, and the hypotenuse of this triangle is side x, and we have here angle alpha. We need to calculate the base. So considering this is the base, we can do Pythagorean theorem to solve for the value of the base of area B. So considering area B over here, by using Pythagorean theorem, we have here c squared is equals to a squared plus b squared. And we have here c squared as x squared and a squared. And b here is 5. So we have that 5 squared. Since we have the value of x already, that is 6.4. So we can solve for the value of a, the base of this triangle area B. We're solving for the value of a, so we can transpose this, isolate a side a over here, so we can get the value of a. So that's the base of the triangle in the area B. So this is a squared is equal to x squared minus 5 squared. So a is the square root of x squared minus 5 squared. And in here, the value of x over here is 6.4. That is 6.4 squared minus 5 squared. That's the value of a, the base of the region of the triangle B. A now is equal to 4 units. So we have here calculated the value of a, the base of the triangle of the region B. Now we are solving for the area of region B. So area of region B, so area of B is equal to 1/2 base is A times height is B. And we have here now 1/2 of A is 4. And side B, or the height, is 5. So area of B is equal to 4 divided by 2, that's 2, so 5 times 2, that is 10 square units. So next will be calculating the area of area C, or region C. So here we're calculating the value of area of region C. To find for the area of region C, if we consider this triangle right here, if we consider this 4 as the height, so we need to find the base of the triangle. Or either way, we can find the base over here, and we consider this as height of the triangle to find the area of this region C. So we need to find the value of angle beta. Since angle beta and angle alpha are complementary, then the sum of these two angles is 90 degrees. Since we already know the value of angle alpha, we can find for the value of angle beta. So we have here area C, or we call triangle C. So here now, angle beta plus angle alpha is 90 degrees. Since we already know angle alpha, so this is now angle beta is equal to 90 degrees minus angle alpha, where angle alpha is 51.34 degrees. Beta is equal to 38.66 degrees. And now we can calculate the base, or we call this base of the triangle, if we consider this as the height. So the height of this triangle now is 4, and the base is now this side as its base, this side as B, as base. So here now, cosine of angle beta is equal to x divided by b. So b is equal to x divided by cosine of angle beta, and b over here now is equal to, where we have the value of x, that is 6.4, and cosine of angle beta is 38.66 degrees. So the value of side B is equal to 8.19 units. So from here we can now solve for the area of region C. So area now of region C, A of C is equal to 1/2 of base, where we have here B as a base, times height is 4. So this is now 1/2 of, so base is 8.19 times 4. So area of region C is equal to 16.38 square units. From here we have already found the value of the areas of the square, the area of region B, and the area of region C. So we can now solve for the area of region A. We have here now the area of region A is equal to area of the square, that is 40.96 square units. It's 40.96 minus area of region B, that is 10 square units. So that's 10 minus area of region C, that is 16.38 square units. So 16.38. So area of region A now is equal to 14.58 square units. It is now our final answer. So this is now our final answer. And so that's all for now. And for those new to my channel, I would appreciate it if you can hit the like button and subscribe for more videos. Thank you very much. Thank you for watching. I will see you on the next video. Have a great day, everyone. Bye.